So example 10 is less of an example and more of what we are doing to um, help solve problems involving expansions. So how can we look at some of the formulas to help us figure things out a little bit more? Um, so if we were to look at, two sides of this real quick, if you had something that was like a plus b to the nth power, okay? Now, how is that going to look? So think back to our binomial theorem a little bit. We would start off and build it as n choose 0, right? So we know we're going to start at 0. We know we're going to count all the way up to n. And we know that a is going to receive all of the powers at first, and b is going to receive none of them. But as we move along, that starts to transfer. So we get a to the n minus 1, and b to the 1, and so on and so forth until it trades off. So we can use this pattern and logically think about how can we figure stuff out. Well, when you're solving different problems, you want to pause and try to figure out all the information you can and try to figure out how to write your terms. So this is a general form of how to write your terms. So sometimes they'll ask, to solve for a coefficient. Sometimes they'll ask to figure out, hey, what in the world is n? So if you know anything about some of these problems, you can kind of help figure that out. Now, let's look at an example. So like if we were to try to figure out like, hey, what is n choose 1? Well, we know that that's going to end up being n. But what about like n choose 2 or n choose 3? So if I had something like n choose 2, that is the same thing as n factorial over 2 factorial times n minus 2 factorial. Well, what that really is if you think about n factorial is the same thing as n times n minus 1 times n minus 2, so on, which is the same thing as n minus 2 factorial. So every time what you're getting is a similarly building system where you have n times n minus 1 over 2. Right? This is a formula that we can use to help figure this out. Now, every time we do that, we can build it and further. You'll notice that if you were to try this out, n choose 3, that would be n times n minus 1 times n minus 2 over 3 factorial, right? 2 factorial is the same thing as 2, but that's how this continues to build out. We can use this to our advantage if we're trying to solve for something. If we know that one piece is this or one piece is that. If for example, I looked at a plus b, and let's say this was to the n, and I want to say, or if I want to do this, again, build all of that out, everything is going to have a particular coefficient depending on what the value of n takes. And again, there's also those powers that you have to look at for a and b. So if whatever they're doing, what are they asking you to solve for? Are they giving you n or are they not? And if they aren't giving you n, what would that equal? Set up the equation and solve from there. You won't be able to use factorial, so you're going to have to somehow eliminate that part. But just look for what's in common, and then you can go from there.